Let's switch applications and go to Tinkercad, because Tinkercad allows us to work visually in an emulated environment or simulated environment, and it allows us to do a lot of circuits. Now, it can't do everything. For example, you can't load in third-party code, and it doesn't have every sensor, but you can do quite a lot, and it's a good way of approaching this from a visual point of view and very quickly tinkering to get some experiments together without having to actually plug things in, scramble around and find parts, and there might be parts that you don't have. So let's have a look. If we create a new circuit, it'll take us to a blank screen, and as you can see, it says there's some pre-made circuits you can have, and there's a bunch of components. So we want to have an Arduino. We go down here, we can pick Arduino, and you could have a blank Arduino, or we could go with the blink sketch. And as you can see, there's various different things like melody, which we'll look at later in the course, and servos and all that good stuff. But let's start with the blink. It's what we're familiar with, it's what we've already played with, and load it in. And as you can see, instead of using a breadboard, they've just got the resistor and they've got the LED there, and we can actually change the color of this wire. I want to keep it black because it's going to ground, but this one, let's make that red, because that's, even though that's attached to a data pin, it's essentially providing it with some current. And we can start the simulation and it'll blink. That's great. But let's have a look at the code. Now, the really cool thing about Tinkercad when you go into the code view is it actually shows you the code in a visual programming way, a lot like Scratch, or if anybody's familiar with Adafruit, they've been promoting a thing called Make Code. It's very similar. So behind the scenes, it is still the C. It's still Arduino C code, but as you can see, there's the various sections that we had in our written code in our online IDE. So it starts with a comment, and we've got the full comment there. It's got another comment to say turn the LED on. It says set the built-in LED to high, so that's switching the LED on or giving it current. Waits 1 second. Can you remember 1000 milliseconds in our code? There's another comment, set it to low or off or 0 or false, and then at the bottom it waits another second, and then it loops around. Now, what we don't have here is an explicit loop. So obviously this is all going to loop, and we can change the code from blocks to blocks and text. So as you can see, it's the same code as before pretty much, and we can have it just text. So it says, are you really sure you want to do that? Yes, I am. What can we do with this? Well, it turns out it even has a serial monitor. So let's add some debugging output. If you're familiar with other programming languages, you'd usually print or printf something to the console to say, this is where I am in the program, this is what my values are currently set to, this is my environment. And it allows you to debug, it allows you to keep track of where you are and where everything is, and it allows you to step through to find out where the problems are. We can do the same thing but using the serial monitor. So what it actually does is it sends this text or whatever values you send to it out through the USB cable to your computer. And so because this is a simulated environment, it's doing it all in the browser, but you can think of it as sending information out over USB from the Arduino to the host computer, your PC or your Mac or your Linux machine that you've plugged the USB into. So let's send some text to the screen and you can see what I mean. First of all, we'll use the blocks method, just so you can get a feel for how this works, because this might be sufficient for what you want to do just now. As you can see, there's various options here, like you can set the pins, you can play speaker, you can turn speaker off, but this is what we want. We want to print to the serial monitor. And what we're going to do is we're going to say hello world, which is the default. And the new line is like a carriage return afterwards, so that it goes to a new line, so you can do another line straight after it. So if we do the start simulation, every time it blinks, it's going to say hello world. Cool. So hello world, why did I choose that? Traditionally, when you start a new programming language, the first thing you're going to learn how to do is print hello world out to the console or out to the screen. So we've done that. We've achieved hello world. Obviously, that's not super useful, so you might want to say this is the LED on. You could say on or LED on. We've got LED on. We might want to say LED off. So we can, again, put another print to serial monitor in and put LED off. Let's see what that looks like when we simulate. We have now LED on, LED off. Excellent. What does that look like in code? If we bring it up as blocks and text view, you can see we've got up here serial begin. So we're starting our serial port, and serial's got a capital letter, so that usually denotes that this is a object. It's special, it's an object, it's not just a variable. So in the convention we put uppercase S to say it's a thing as opposed to a variable, and we say begin. We tell serial to begin at 9600 baud rate. So that's the timing, that's how fast it's going to read and write to the serial. We can change that to 115-200 or something else, but 9600 is fine for now. In the loop, we then print a line to the serial. We tell serial we want to print a line, and within these quotes, explicitly, I want to send LED on. So this is exactly what we want to send to the console, to the serial monitor. We want to send LED on. Those quotes say this is the exact precise text we want to send. And another way of saying that is it's a string. So we've got serial object, please print this out, this exact phrase, LED on. And you start it with a quote and you end it with a quote, and then it's surrounded by brackets to say, I want you to do this. And then you notice every line finishes with a semicolon. And when we go low, when we turn the LED off, we do the same thing, serial print line, LED off. And it'll keep doing that forever. If I now bring up the desktop IDE, you can see the same default text is there, the structure, and I can paste in this code that we've been working on and see how it works on the desktop. Up here I need to choose the port, so I've got two Arduinos plugged in, so I've got two ports, and it doesn't really matter which one I'm going to choose. And I haven't got a Mega 2560, I'm going to go for my Genuino Uno, and I can hit save and say blink serial. So it's blinking and it's serialing. Just like before, we can verify, you can make sure that there's nothing in here that's going to break it. So it's compiling, seeing if it's going to work. It's very slow. And it's done. So that's alright, no complaints there. So I can upload. And the lights flash on the Arduino. It's done, and it's blinking the LEDs. So again, we've got a serial monitor. Remember, we chose 9600, 9600 for the serial monitor. It's important that you choose the same baud rate, and as you can see, it's not the right baud rate, and so it's not working. So we have to match 9600 here, and then it works. LED on, LED off, yada yada yada. Let's change that now. Let's put something else in. So up here where we've got serial begin, we could say hello world again. That's okay. Hit save, upload. Ooh, we've got a mistake, and that's because, remember, we said semicolons. That is one of the most common mistakes in any C-like language, missing off that semicolon. So we do it again. We upload, the lights flash. There we go. Hello world is output at the start, and then we've got a loop. So that demonstrates that we've got the setup that runs once, and then we've got the loop. How about a bit of homework for you? We've got the light blinking on and off. It's plugged into pin 13 on the board, if you remember, and ground. But we're waiting a second, 1000 milliseconds between blinks. So what can we do? We can change how often it blinks. We can change how often it's off and how often it's on. We can blink twice and then have a long blink. We could do SOS. Have a play with it. I'll show you a really quick example, and then you can have a tinker, and we can come back to it in the next lesson.